I've been running manufacturing companies, building skylights, solariums for 10, 12 years, industrial woodworking, dry kilns, laminated beams. Last 15 years, prefab housing, certified to CSA 277. So that's given me 35 years or so of experience seeing how materials are actually worked with and how workers put assemblies together and how drawings and plans are followed or not followed. I was asked to find a material that could be used as a parging board for a prefabricated light steel foundation system a couple of years ago. I did some internet research. I came across the magnesium oxide board, and it just looked too good to be true. It comes out of China, so that raised some red flags. I found an American company, Magnum, who had been working with the product for about 7 years. They had UL/ULC certification, meaning the factory is audited, and they had done most of the testing to get the American ICC certification. AC 386 is the exact one. And so I jumped on a plane, flew to Florida, and arranged to be the Canadian representative for the Magnum flavor of magnesium oxide board in Canada. The things that appealed to me were really, it covers all of the main characteristics as far as being sustainable environmentally, made appropriately. It could be neutral to maybe even negative greenhouse gas, extremely durable compared to all the different flavors of gypsum and also fiber cement, and also as non-combustible structural sheathing. It's not that expensive. Half-inch board going to market will be around about $1 a square foot. And as you saw from the video, it's very easy to use. So all the standard tools that people have work with this material. Now, part of the interest of this product to me is the history. This is perhaps one of the oldest cements used by humans. Magnesite, which is the ore it comes from, can be calcined at low temperatures, and there are indications of magnesium-based cements going back to the Romans, Great Wall of China, so a lot of different things. Stanislav Sorel, a Frenchman, rediscovered magnesium oxychloride cement in 1462, and it's been used to this day as Sorel cement. It's used for oil well drilling mud, it's used for patching cement for bridge decks and airport runways because of its very high strength, fast set characteristics, also for industrial flooring. Van Stainer is the American who's credited with reverse engineering the mortar in the Great Wall. About 50 years ago, people wondered how come the mortar's outliving the stone in part of the Great Wall. Van Stainer, who has patents for some of the magnesium oxide phosphorus cements for oil well drilling mud, figured it out, and over the last 50 years, the rigid board that you have as coasters or the other samples in front have been developed in China, so that these are some of the ancient sort of uses for it. And here's a more modern use. Type A 101, all the walls and floor assemblies inside and out use magnesium oxide board for both fireproofing and decoration. The Beijing Olympics, it was also a premier material. Its first exposure in North America is about 2003, and so Magnum was one of the early adopters there. Also, a group of companies in Alberta who started making the MIPS, the new coin for the insulated panels. So there are now about 3 companies in Alberta that are pressing insulated panels, and there's about 7 years of history of that product in Alberta. But in BC, really, we started to promote it about 18 months ago by doing presentations like this to people like you. So it's got this pretty cool history. The other interesting part is the composition of what it's made from. Magnesite is the 7th most prevalent mineral in the Earth's crust. It's also prevalent in the ocean. Magnesium chloride is the 3rd most prevalent mineral in the ocean. Those two materials, the magnesite is calcined at about 400 degrees, which makes magnesium oxide. That's about 1/3 or 1/4 of the temperature and energy required for calcium carbonate to become lime. And when it's made here, the carbon that's driven off during that process could be captured. Currently it's not, to the best of our knowledge, with the product made in China, but when it is captured, that will give this product an incredible environmental carbon footprint, maybe even carbon negative based on some research that I've read. Magnesium chloride currently mostly comes from places like the Great Salt Lake. It's used as a road de-icer. So you've got two materials that are required for the health of people, plants, and animals that mix together form the cement. Magnesium oxide chloride cement bonds structurally to cellulose, contrary to Portland cement. So when the cellulose wood flour is added, there's an actual structural bond, meaning that the composite material is stronger, and that gives the material better, faster holding capabilities. The perlite, and in some cases vermiculite, is added to basically reduce the weight. Fiberglass mesh gives us some tensile strength, and in our case there's some talc to give the one surface a white, smoother appearance. Not all flavors of the board use that. So really that's the ingredients of it. There are some types of magnesium oxide cement that add phosphorus, and that gives it some extra characteristics, which I'll talk about a bit later. It's a very clean extraction process. The mine on the right is in Invermere, BC. The purity of the mineral, of magnesite, magnesium carbonate, is about 95 to 98% coming out of the ground. So there's no tailings, there's no chemical conversion. The material goes to Exshaw, Alberta, which is the picture on the bottom left, where it is calcined and becomes magnesium oxide, which is then used for a variety of uses, from pharmaceutical, pharmacological, industrial, and now in North America it's actually starting to be used to make board. There's still currently only one pilot plant in the States, and that's in Houston, Texas. They're using the Baymag magnesium oxide because it is some of the most pure stuff. There's another product called Flame Block, which is a layer of magnesium oxide added to OSB. It's marketed through Louisiana Pacific, and about a 16th inch layer of magnesium oxide added to OSB gives it a 20-minute fire rating. A company called Barrier Technologies actually makes that product and markets it through LP. So the process of making this is also very environmentally friendly. It's very low embedded energy. When the two ingredients are mixed together, and they need to be mixed together appropriately, it's an exothermic reaction. To cure properly, it needs to be at about 25 degrees Celsius for a number of days. Our product comes from Guangzhou, China, where that's pretty well the ambient temperature all the time, and so we have good comfort that we have a fully reacted product. The risk with this material, if there is one, is if the reaction between the magnesium oxide and the magnesium chloride is incomplete, meaning they are added together in the wrong sequence or the wrong temperature, then there is excessive free chloride ions in the finished board, which are highly soluble, and in prolonged is water contact that could degrade the board somewhat. The Chinese government puts a maximum of 10% free chloride ions. Our board is about 5–6%, but that's the one, I guess, caution with this product, if there is one. Adding phosphorus to the mix actually renders the product insoluble, and that's the material that we find that's got a couple of thousand years. They got their phosphorus from fermented plants or animal waste, dung. So the analogy I like to use is you can have a couple of people in a kitchen with the same ingredients, and they start to make a cake or a loaf of bread, and one of them will get a cake or a loaf of bread, and the other will get a pancake. Same ingredients, same kitchen, same everything, but the slightly different way of putting it together, it either rises or it doesn't, and in this case we either get the complete reaction or we don't. And so that's the one major thing that I've learned over the last year to make sure we have a durable, predictable board. The paste is put onto a sheet, a smooth sheet, the smooth side down. It takes about an hour for the initial set, and then several days for curing. After those several days at ambient temperature, it's then cut to size, and in our case it goes through an abrasive planer, which gives it a close tolerance thickness. And really it's that easy to make. So it's a process that could be replicated anywhere. Our goal, big picture wise, is to use the Canadian or the Chinese made product to develop awareness, because I go into rooms like this almost a couple, 3 times a month, and nobody puts their hand up. So my main job is education. Within a couple of years, though, we want to be making the board here. All the raw materials are here. They're of higher quality and purity. We can obviously control the production better. We can make the board lighter and stronger. There are already concepts and formulas to do that, and so that's our goal. It'll be one of the first times that a traditional Chinese industrial product in manufacturing comes to North America to save money. The cost of our board, if I sell it for $1 a square foot here, 40 cents of that is the shipping cost from China, because it's relatively heavy, although lighter than fiber cement. It's got some great features, the magnesium oxychloride cement itself, depending on how it's made. Carbon neutral. There's a product called NovaChem, developed at Imperial College in England, which won global awards as a carbon sequestration material. More recently, there was an article about a Dr. Michael Hitch at UBC, who was doing research with magnesium silicate, which is found in all of the mine tailings in BC. He found a way to mill the molecules or the ore in the tailings so that it increases surface area. It causes it to uptake atmospheric carbon dioxide, forming magnesium carbonate, and Michael's idea was to use that as a carbon sequestration. To get a new cement material accepted into the North American Building Code, though, would be a long, arduous process, and so we came to him with our product, which has already got basic market acceptance. So we have a relationship now with UBC that we are going to use to properly quantify the carbon footprint of our product. It's a very important motivator for me. It bonds with a variety of fillers, not just cellulose. So one of the things that we are starting to work with is FP Innovation's new nano cellulose fibers. That could be another way that we can increase the properties of the board. The ingredients, as you see, are safe and healthy. They're suitable for people with hypersensitivity to chemicals. There is no outgassing. There's no formaldehydes, things that you find. There's no silica. There's no carcinogen. So comparing with the fiber cement or the gypsum, this product is very safe, healthy, and benign for people to use. And unaffected by most industrial paints and solvents, and there's been a lot of history in North America with magnesium oxychloride cement used as industrial flooring or in hospitals or other sort of industrial floors. One of the great benefits that I think is the antimicrobial nature. The ingredient magnesium chloride, salt, prevents mold. I've had pieces of the board, this is tested, and all these claims that I make have passed various ASTM tests, and we will share those tests with you. But I also do field tests at home. I left pieces of board out on my north-facing deck all winter. The deck is green, the boards are still white. No mold grew on it, and no mold actually grew on the boards that the MagO was in contact with. We have seen incidents of wood frame construction, site built, where the back of the gypsum is black because of the new energy code, wrapping the building tighter and encapsulated moisture in the framing. The gypsum paper is a petri dish for the growth of mold, and I think that is going to be a bigger issue coming up. The MagO board, or in the States, Magnum, we've underdone, I don't know, now 35 tests or so. These are sort of the high points. The latest non-combustibility for Canada we did last fall. Not on here. We just recently did STC testing at the Elwha Sound Labs in Washington State. Phenomenal building. a repurposed nuclear reactor built in the 70s that was never turned on. And now the only tenant is a guy that set up the world's quietest room next to the reactor chamber in this nuclear facility in Washington State. But we got an STC 55 with one layer of 15 mil board on a party wall. It's our goal to do the next couple of tests to have this board become the de facto party wall by doing a combustible fire assembly. We fully expect one 15 mil layer to get us at least 2 hours, maybe longer, based on other tests that are done, and we need to do a sealing test. The option that provides to us then is to provide a party wall that can be erected and fireproofed by the framers during the construction of combustible multifamily buildings. We were involved with the first 6-story when I was prefabbing houses in Richmond that burnt to the ground. I was presenting to the Alberta building officials when a condo project burnt to the ground in Alberta last October, and a lot of us saw the pictures of the one in Ontario where the crane operator got rescued by helicopter from the pointy end of a crane as the condo project burns down behind him. This board can be applied by the framers using their standard tools, carbide saw, nail gun. It would add shear value to the interior walls. One side of a party wall gets done. The ceiling, we've now compartmentalized the building during construction, and once the building's locked up, that wall can be finished and become the finished wall surface. So that would be cost savings and time savings, and limit the chance of these wildfires going through condominium projects. Sorry, yes?
So you're suggesting that the framers would put the gypsum, put the board on the inside. Who would do the insulation? Would you do the insulation and vapor retarder from the outside?
Well, for the outside wall, you might not put it on because that's an outside wall. But a party wall, if you do one side of the party wall, you can still access that for wiring and servicing. And then when the building is locked up, and that would still compartmentalize the building. But there's no need to do the outside wall really because it doesn't spread anywhere. So we haven't done one of those projects. We've talked to Len Garris, the fire marshal. We've talked to other people about it. Samir Adnani at CFT is our go-to code consultant for all things fire, and it seems like there's a lot of rationalization behind it, and I can't see any reason why it won't work. But obviously, the devil, as always, is in the details. When we first started to market this, we looked at it and we thought, my goodness, it does so many things, we're going to be scattered. We got to focus on something, and we originally focused on interior wallboard because it's ubiquitous. Every building in North America has a huge amount of it. Gypsum is not a great material. It works really well until anything happens to it. Insects, water, impact, and then it's a toxic waste. Gypsum and water, hydrogen sulfide, which is not nice stuff. So that's what we first went after. And I think when we are looking at applications that need high impact or resistance to water, and so New York has outlawed paper-faced gypsum if it's in a water-prone area. Richmond's considering it, they have a bylaw. Calgary did it. If you rebuild in the flood zone in Alberta, no paper-faced gypsum. New Orleans, the same thing. So now there's an alternative to paper-faced gypsum that would be resistant to any flood water or sprinkler water. And even if it does get wet, and I've had pieces now that I've run through my dishwasher 8 times and counting with no degradation, the board could actually be taken off and put back on if we want. So it gives a lot of extra abilities to make better buildings. Some of the other things, it does have a structural capacity. There are some tests that have been done. It is similar to OSB as far as its resistance to shear, but you guys are more the experts there. It's easier to finish to a level 5 because the surface is much smoother. It doesn't require plastering over the whole surface. And one board will do all of these jobs. It's not like gypsum where you have to pick between one of 8 different flavors. So that makes it more predictable that the right board will be used in the right place. The other secret to having your designs properly enacted on site is the ease of working with the material. Building houses in a factory, if a client wanted to use hardy, WorkSafe required me to have fresh air respirators for the workers because of the silicosis. You need diamond saws. If you need special equipment or special methods to work with the product, then there's a chance that isn't going to be followed all the time. I think that's almost a certainty. This product seems to be extremely forgiving. It uses all the standard tools in a carpenter's or a drywaller's toolbox, and it's very forgiving to use and to finish in a number of different ways, whether you follow the suggestions we have or whether people put it up just like gypsum or as a replacement for hardy. The expansion and contraction is much less, so even if they close fit the joints on an exterior paneling, we're not going to get the issues that you might with a cement fiberboard. This is a monolithic product, so it's not going to delaminate. So we don't care with the exterior cladding if the screws are countersunk or if the panels are closely fit. It worked with a variety of construction adhesives and a variety of fasteners. Because of the magnesium chloride, the fastener should be coated, but almost any coating works. In fact, Grabber tested their phosphorus-coated drywall screws, which is a very mild, non-corrosive coating. They actually found that the magnesium enhances the protective nature of the phosphorus. Some of the other benefits are the simplicity that this brings. I sort of mentioned a bit that when you're a specifier designer, you've got to pick which sort of gypsum if it's inside. The guy estimating has got to price the right one, the guy's got to buy the right one, and then the guy on site's got to put the right board in the right place. Based on watching people work in my factory for 30 years, I can promise you that that doesn't happen all the time. Expansion and contraction is very low, either hygrometrically or thermally. I think the math is a 10-foot board in Edmonton, a delta of 70 or 80 Celsius, it's less than a 32nd of an inch. There's a job in Edmonton right now, they got to take 900 sheets of certainteed off because they've all failed due to expansion contraction. So we don't seem to have that problem either. I've taken this board, it's a concrete board, so it'll absorb 27% by weight of water. And I've soaked the boards to that capacity, wrapped them in plastic, and then put them in the freezer. And nothing happens. I don't know where the expansion of the water goes, but the board doesn't change size, it doesn't change strength. When I take it out of the freezer and let it dry, it has the same characteristics it had before it went through that test. The ASTM test is 50 cycles of that sort of exposure. The outgassing, the impact, you saw the hockey puck. We've had hockey players actually shoot hockey pucks at it and give us comments about that. And the safety for workers. It does make dust. We absolutely don't recommend people breathing dust of any sort, but this is a health supplement. So the dust is a bad issue, but the material itself is non-toxic, which is a better issue. With the 12 mil board, our 1 hour certified fire assembly is a 12 mil board, 3.5 steel 12 mil board with rock wool or bad insulation. That's a W490 UL registered assembly. There are some other assemblies that have been done, but that's a work in progress for us, as I mentioned before, to get combustible assemblies and floor assemblies. If some of the shear can be moved to the inside, that's going to make our building stronger and give designers greater ability to, design more flexible and interesting buildings. The amount of time that contractors spend to put backing to attach grab bars or cabinets. If you have a 12 mil board and we put a screw just in the board, it can handle 200 pounds in shear, one screw. I've had an 8 mil board and put a hook in it, and from that hook suspended 9 gallons of water. I put it up in October on my deck and I took it down in March. And we went through enough windstorms that blew my picnic table over. And that connection is still there. The board is still as strong as it was. So its faster holding ability is pretty strong. So as a replacement for, say, Dens glass, is an exterior sheathing. we can attach the cladding directly to it, which will simplify those assemblies. We're currently working with RCABC to get the material approved by them. We haven't yet had it in front of Suprema or SBS membranes to check for adhesion with that. I don't see any issue with it, but those are steps we still have to go through. But definitely to be in conjunction with roofing membranes or as an exterior sheathing for non-combustible construction, I think this is just better. And it's about the same price as a dense glass as well, with less effort spent on the labor. The other thing is that this material is fully recyclable. When we make the board here, it can be ground up and put back in it. We also have a company called BC Garden Tea that make a very high-end liquid fertilizer. Now, plants need magnesium to photosynthesize light. We need magnesium, and we usually get our magnesium by eating vegetables. Because of the incidence of processed food in the States, there are magnesium deficiencies, but even the waste that we don't have any other thing to do with it can be ground up and used as a soil additive, which will help replenish the soil and put more magnesium in our diet. So it has a full life cycle of use. Faster construction, if you don't have to need corner beads. This is a sample corner that you guys can touch and feel. I can drive nails with that. And that is a outside cladding corner, but that's the same assembly that we would use on an interior. That corner's been around now for about 5 months. I've dropped it and hacked it and banged it, and it's still a very durable corner. So it speeds up construction. If you don't have to have drywall tapers coming back 3 times, you could save a week on construction. Now, about a year ago now, we were called by Raffi Architects because a material that they had recently adopted, the Ceraclad exterior cladding system by Panasonic, Panasonic pulled it from the market. And Raffi Architects wondered if we could come up with an alternative. And so we sort of changed direction because that gave us immediate distribution with Mitten Exteriors and a bunch of jobs, a couple $1 million worth, where the Ceraclad had been enshrined in the development permit. And so we set about replicating a clip-applied, face-sealed, integral drainage cavity cladding system, which we now have as the MagO cladding. So here's a sample of the 2 boards with the profile. Pardon?
Is it just glued together?
There's pin nails to hold it during the gluing. But that's a single cure, moisture cure urethane adhesive is what holds it together. So these panels, it's basically a made in BC product now. We bring in the product in 4x8 and 4x10 sheets. We bring it in 3, 6, 8, 10, 12, 15, and 20 millimeter thicknesses. We have the boards ripped and profiled locally on CNC equipment. We got Hansen Industries to make the clips, so they're made in Richmond. We finished our first pilot project with this. It's cut on site with carbide tools. We actually have a router that the people can add the profile to the edge in the field. We can also supply a variety of finishes. What you've got there is a MagO's acrylic top coat. MagO has approved their acrylic top coat and their polymer modified base coat. Either or, we don't need to do the 2 together. Cloverdale Paint has formulated paint to go on it. Sherwin-Williams has approved paint coatings for it. Not every primer sticks to this board, so finding the appropriate primers has been a bit of work, but we have a few of those that work well now. And because the first job we did, the client wanted to do some panels vertically and some panels horizontally, we have re-engineered this so that the edge details on 4 sides, meaning that the system can be fully applied without caulking, really in any weather. Because we also fabricate those corners, we can make those any size, any angle. And we can make trim pieces and lintel pieces. We can actually carve in the board with CNC routers, so we can provide the designers a wide range of possibilities. We also provide site inspection and estimating. Some of you may know my partner for 15 years is Jack McQuaig, McQuaig and Associates Engineering. So he is the technical side of this company, and if people need more technical information, just call Jack, and he can fill you in on that. But he's been my partner in Chateau Homes and now in MagO for about 15 years. So with his services, he recently got errors and emissions insurance, so he can now work on our jobs, which has taken years to get. But that is another service we're prepared to offer. We get a bunch of lead points. This is my assessment, so I'm not going to really go over that. Nobody's questioned them. Somebody said we can get other points. When we make the product here, this will definitely be the most sustainable and durable locally made product. The other big issue for us is the code compliance. This is not, does not have CCMC. Most of our initiatives have been to architects, engineers, and all of our first customers have been municipalities. So City of Richmond, we're on our second job, the Langley Township Water Treatment Plant, Pitt Meadows Community RCMP Station, Ladysmith Wastewater Treatment Plant. Those are our first projects. We've ended up doing our first MagO cladding job on a Part 9 building, which of course made us have to make the building inspectors happy there, which is why we had to get the errors and emissions for Jack. I've presented now to the BC building officials for the last 2 years, and also to the Alberta building officials. The Alberta Safety Services branch actually paid me to present to them in Banff about a month ago. After the Vancouver BC building officials annual general conference, we were speaking with Bruno Di Leonardo, who was with NRC, CCMC. The week after that, I got a call from Brad Gover, who is the director of CCMC, and they have invited us to work directly with NRC, CCMC to develop the testing protocol for magnesium oxide boards. So CCMC is in an interesting position that they don't generally do work on new materials until somebody gives them money. Nobody has given them the money to develop their testing protocol so far, but they have 3 people on the team. We have recently, a couple of weeks ago, registered the Magnesium Oxide Cement Association of Canada. We are gathering the handful of people that are using the board in Canada now, and we will be working with NRC to develop that testing protocol. Our fear and what we want to prevent is that some of the less rigorously made product in China doesn't come to North America, that we can keep a good solid baseline quality standard, and in 12 or 16 years get this actually in the building code. When we look at, thank you very much. When we look at, yay, usually somebody will take the little coaster and break it, but you're the first person that's done the corner. So our goal, working with the with NRC, like I say, is to get this into the building code. When I look at the intent statements and the objectives of the building code, gypsum doesn't actually kind of meet. It's non-compliant. And from Samir Idnani's point of view, this guy, when the gypsum people go to do a fire test, they send a truckload of material. They send representatives from the big 5 gypsum manufacturers. They cherry pick the boards and put them up in a specific way, and then they fail 9 times to pass once, in the best case. And that's what we rely on for fire separation. And they have to stop the test in the middle in order to do the hose stream test, because at the end of the hour, 2 hour, whatever, gypsum lasts less than 4 seconds with a fire hose. The magnesium oxide board doesn't allow water through the wall assembly with the fire hose. So it's significantly better in all cases of fire and impact. You saw the first video. These are close-ups of that very quickly made wall. Top left is the outside corner, top right is the inside corner. The bottom left in the middle of that picture is the T-joint. So even putting the boards together using that methodology, none of the joints telegraph through. And this is our first MagO cladding job. So this is a residence in Capitol Hill, Burnaby. This went together very nicely. The clips and stuff, they painted the product on site. We've ended up with an extremely clean finish. You can see the UL mark on the bottom right-hand corner. So the guys were, the owner and a worker were putting panels up about every 15 minutes a panel, and we have very happy campers there. And I think we're about to do our first job for BCBC, a school out in Mission. And some more shots of that. This was the first job we did for the city of Richmond. This is an interior wallboard, the Hamilton Childcare. That was successful. They've now put us into a community center that's getting built. Richmond is actually, we've had 4 meetings with senior bureaucrats in Richmond. They're actually talking about making this mandatory because they have a bylaw that states material used in water-prone areas, which is really everywhere in Richmond on the ground floor, should be moisture suitable materials, and they keep issuing easements because until now there isn't a solution. They also see this potentially as a way to achieve their greenhouse gas remission targets. This is the Pitt Meadows RCMP Community Center. This was a direct replacement for an 8mm Hardy or Certain panel. The main difference with this was Ratio Architects designed this. The walls are over wood framing, wood battens. The soffits are over hat track and metal, as are the buttress assemblies. The architect has used the Fry reglet system to frame the panels. As you notice, perhaps you can't see any screws because they're all countersunk and filled. And this job and the one before were both painted on site. Very easy to do cuts because the guy just needs a carbide saw with a disposable blade, doesn't have to worry about the dust. Same with putting in pot lights or electrical fixtures. You can use routers, jigsaws, so you can do much closer tolerance cutting than is easy to do on a fiber cement product. Top left is my Buildex show. That little cabinet there is 12mm board. It's held together with Stanley angles, 2x2, and number 8 half-inch screws. It's gone through 2 Buildexes so far, and I'll use it again. Bottom right, project in the Bahamas. Head office for Magnum is Florida, so a lot of stuff has gone on in the Caribbean. That's a light steel structure. The Magnum board is used for interior wallboard, exterior wallboard. It's also cut into 2-foot strips and applied shiplap for the roof. And then they spray an acrylic elastomer over the whole roof. Shiplap siding as well. Currently we can rip boards, and at some point we will have a wood grain pattern and build furniture with it as well. That's the end of the presentation.